right, welcome back. Hopefully those recursive formulas went okay for you. So today what we're going to work on is finding different terms and finding term numbers. And so we're just going to kind of work through a bunch of these. Really, you're going to use your explicit formulas a lot for arithmetic and geometric. But there might be some slightly more difficult situations that are a little bit trickier to write those equations or try to figure out what exactly is going on here. So we are going to do all of the odds on these first 2 pages of notes. And so your assignment will be to do all of the evens. So I'm just going to let you know as you're working, if you want to, after we do the first one, hit pause and you do the second one and then come back. That could be a good way to work through your assignment today. All right. All right, so the first one is we have the sequence 39, 44, 49, 54, and we are looking for a sub 39. And so, hold on, let me adjust this real fast. So a sub 39 means you're finding the 39th term, right? The 39th term. So one thing you could do is you could recognize, oh, hey, this pattern adds 5 every time. And if I wanted to get to 39, I could literally just sit here and add 5 until I get to the 39th term. That is going to take a long time. So highly recommended that you use your recursive formula that says, all right, a sub n, any term you want to find, start with the first term. You're going to add 5 times by n minus 1. And you can specifically find the 39th term by plugging in 39. So 5 times 39 minus 1. So you're probably going to want a calculator here. Whether you have one on your phone or you want to just use one on the computer, either one is fine. So 39 plus 5 times, and here you can either write 39 minus 1 or you can just go ahead and say 38, right? And so we have 229. So your 39th term is 229. So if you were to take this sequence out a bunch, then spot 39 would be this number, 229. All right, so here's another sequence, but we're given the recursive formula for this sequence, and we need to find a sub 38. So we're looking for the 38th term in this list. Well, we know the first one, that's negative 27, and we know what's happening. We're subtracting 200 every time. So your first option, you could take this, subtract 200, 30, however many times until you get to the 38th spot, right? That's option number 1. Option number 2 is go ahead and write yourself an equation, an explicit equation. So the first term, negative 27. What's happening every time? Well, we're subtracting 200 times n minus 1. So the 38th term would be a sub 38 equals negative 27 times 2 or minus 200 times 30, 38 minus 1. And once again, you can just throw that in your calculator and let it do all of the work for you. So negative 27 minus 200, and then 38 minus 1, if you want to go ahead and just plug in 37 there, that works really well. So negative 7,427. And we would expect this number to be slightly big because we're subtracting 200 and we're doing it 37 times technically. So I think that number is pretty realistic. All right, next one we have the first term is negative 28. D, and you kind of have to remember what D stands for. That is the common difference. And the common difference is what we are adding / subtracting by. So because this is a positive 200, the common difference is we're adding 200 every single time. And so it says find the 23rd term. So we're going to go ahead and write the explicit formula. Well, the nth term is negative 28 plus 200 times n minus 1. So if I want the 23rd term, you're going to go ahead and just plug in 23 for n. And then use your calculator to do all the heavy lifting there, right? So negative 28 plus 200 times, what was it, 23 minus 1. So I'm just going to put in 22, sorry. And we get 4,372. And once again, I think that number makes some sense because we're adding 200, so it's going to get up there into the thousands relatively quickly. We're not doing it as much as the last one, so I think that makes a lot of sense, just kind of in general what that number is. All right, here is your next one. A sub 2, that's a huge difference, isn't it? Because now it's no longer a sub 1, it's a sub 2 is negative 22. D is negative 7, so that means that we're subtracting 7. It's the same as this last problem where it was the common difference and it told us what we were adding or subtracting. So we're subtracting 7 and we need to find the 35th term. So we're going to start by writing our explicit formula. Now when we go to write this spot is reserved for a sub 1. We don't have a sub 1, we have a sub 2. But we know what happened was we subtracted 7. So to figure out a sub 1, you're going to use a sub 2. Well, if you had to take a number and subtract 7 to get negative 22, you can find out by adding, right? Adding 7, doing the opposite to move backwards. So that would make your first term negative 15. So when you go to write your equation, this one's a little bit harder because you actually have to think about what that first term is going to be. So first term is negative 15. So if you subtract 7, you would get negative 22 for your second term. So that works. So minus 7 times n minus 1. And for this problem, n is 35. So we're looking for the 35th term. Minus 7 times 35 minus 1. All right, so negative 15 minus 7 times 35 minus 1, so times 34. We get to negative 253. And I think that number makes sense for this problem because we only subtracted 7 every time, so we weren't subtracting this huge number. If you didn't catch that said a sub 2 and you wrote it as a sub 1, you'd be one term off. You'd be one term too far down the line. All right, here is the next one. Ooh, we have a sub 25. So we're starting with the 25th term, and we need to find the 33rd term. And so you actually have some options here, right? You could write the explicit formula if you wanted. To do that, you'd have to go back and find the first term. Or you can kind of say, okay, well, if this is the 25th and I'm going to the 33rd, you can kind of imagine what's going to happen there. So for example, if this is your 25th, it'd be 26, 27, 28, 29, 30, 31, 32, 33. This would be your 33rd term, right? So you would take this number, you would add 200, and then add 200, and keep adding 200 until we get there. And so that's actually not a bad option, is you can just say, okay, well, if I have the 25th, I'm just going to add 200 however many times I need to get to the 33rd. Another option is you can say, okay, well, if I have the 25th term, I can add 200 and just write an equation. Well, how many times do I have to add the 200 to get there? Well, 1, 2, 3, 4, 5, 6, 7, 8 times. You have to add it 8 times. So this also would give you the 33rd term. Now know that 8 also comes from 33 minus 25, doesn't it? And so this is actually a play on the explicit formula. Instead of the first term plus your common difference times n minus 1, it's the 25th term. And then instead of n minus 1, it's n minus 25 because you're starting at the 25th term. So really this is a sub 25 plus 200 times n minus 25. And the 25s there would match. Instead of it being the first term and the n minus 1, it's the 25th term and minus 25. All right, so that means that we can throw this in our calculator and it will take care of it for us. Plus 200 times, we said the difference was 8. 8 times you have to add 200. So 6,363. So there is your 33rd term. So a little bit more complicated based off of what we have going on there. All right, and last but not least, I hope you've noticed that these have all been arithmetic, and so this is the last arithmetic one you're going to see. We will transition to the geometric ones on the back. All right, so we have a sub 19 and a sub 30, and we want a sub 38. Well, the easiest thing would just to be go from 30 to 38, right? If you already know 30, just 8 more times, whatever we have to add or subtract, would give us a sub 38. The problem is we don't know what to add or subtract. This last one just straight up told us. This one, it doesn't. And so that's why we have to use the a sub 19. We have to figure out what are we adding and subtracting. So the first kind of idea here is we need to figure out D. In order to figure out any term, you got to know D. So I'm going to kind of split this into two parts. The first part is to find D. So there's actually quite a few ways you could figure it out. My in-person group, when we taught them this lesson, they looked at these two and they said, okay, well, it goes from 19 to 30. So that's 11 terms, right? So what has happened, whatever D is, has happened 11 times. And we went from negative 373 to negative 593. And so they said, okay, we'll find the difference between those and divide it by 11. That means it's happened 11 times. And that should tell us what the D is. So they went 593 minus negative 373. And so that will turn into a plus. And they said, okay, we're going to divide it by 11, 11 being 30 minus 19 to figure out what was the constant that happened every single time. So negative 593 plus 373, and then they divided that by 11, and they got negative 20. So that means that the common difference is negative 20. So what's happening every time is we are subtracting 20. So if you start here, subtract 20, this would be your 30th term if you subtracted 11 times. So then from there, you have to find the 38th term still. And so they went ahead and based it off of this term, the 30th term. And they subtracted 20, and then they had to figure out how many times do we subtract 20? Well, we go from 30 to 38, so we subtracted 28 times. Throw that in your calculator. We have negative 593 minus 20 times 8. So negative 753 for your 38th term. So if they don't give you first term, second term, if they don't give you common difference, that makes these equations a little bit harder because you have to do a little bit more solving there for sure to try to figure out what's that common difference and then use that to find your next term. So the first part of your homework is to do all of the ones on the right-hand side, so all of those evens 2 through 12. And then we will continue with the geometric ones. All right, so here we go. Here's the geometric. So find each term. We have just a geometric sequence, and find the 11th term. So the easiest thing to do is go ahead and write the equation. So what's happening between all these terms? Well, it looks like we're multiplying by a negative. And to go from 2 to 8 to 32, that's times by a negative 4. So sometimes it's easier to look here in your sequence than it is to look at the very beginning. Like this was a pretty obvious times by 4, and that was a pretty obvious times by 4 as well, where this might not have been as obvious. So your 11th term, a sub n, is going to be 0.5, first term, times negative 4 to the n minus 1. So to find the 11th term, you just plug in 11. Now, because this is an exponential, it's a geometric, so the x, or in this case the n, is in the exponent, we expect this to grow pretty fast. So 0.5, parentheses, negative 4 to the power of, it was 11 minus 1, so I'm just going to type in 10. And I expect a number to be that big because we are timesing by negative 4 10 times. So the higher the term number you're looking for with these exponentials, you would expect to see this number to get really big really fast, especially compared to your arithmetic. It's going to grow so much faster. So that term is 524288. So 524,288. All right, here is the next one. Find a sub 9. We have the first term is 2. To get the next terms, because this is the recursive, so to get the next term, you take the term and multiply by 2. And then to get the one after that, you would times by 2. And so it's easiest if we go ahead and just write the geometric formula for this. So first term is 2. We're timesing by 2 to the power of n minus 1. So this would be 2 times 2 to the 9 minus 1. That's going to tell us the 9th term. And we can just use our calculator here. So it'd be, 2 to the power of, not even close, 2 to the power of 9 minus 1, so power of 8. And we get 512. And I expect to see a number in that range. Remember, you're just multiplying by 2, so it's not going to get as big as if we were multiplying by 4, right? 4 is a much bigger impact there. Plus, we did it less times. Before, it was 11th term, so we were going out further. This is just 9th, so we're not going out as far. All right, here is the next one. First term is negative 0.5. And the R, remember R stands for common ratio, and that's going to tell us what we're multiplying by. And so that common ratio is 4, so we're going to multiply by 4 every time. So let's go ahead and write the equation. A sub n equals negative 0.5 times 4 to the n minus 1 power, and in this case, n is 9 because we want the 9th term. So A sub 9, negative 0.5, 4 to the 9 minus 1. And I would expect this one to be probably slightly bigger than the last one because this is base 4 where the other one was just base 2. So we're going to throw it in our calculator, negative 0.5, 4 to the power of 9 minus 1, which is 8. So negative 32,768. So it did get bigger, faster. I know it's negative, so technically negative numbers are smaller, right? But the actual, like the absolute value of this, the actual value itself did get bigger, faster because it was a base of 4 versus a base of 2. All right, here's the next one. Instead of having a sub 1, they made it just a little bit harder and gave us a sub 2. So when we go to write this equation for a sub n, we have to go back and find that first term. Well, what's happening between the terms? We're multiplying by 2. So if you want to go back and find the first term, you would do the opposite of timesing by 2, and you would divide by 2. So 4 divided by 2 is just 2. So first term is 2. Common ratio is 2 to the power of n minus 1. And we're looking for the 11th term. So a sub 11, 2 to the 11 minus 1. So power of 10 for 11 minus 1. You could write in there 11 minus 1, right? Either way is fine. So 2048. All right, up next, we have a sub 4 equals 32. R equals 4. Find a sub 11. So once again, we're going to write the equation, a sub n. We don't know the first term, but we know it's going to be 4 to the power of n minus 1. So what we need to do is we need to figure out what is the first term so that we can put that number in there. And this one's a little bit harder than the last one because the last one we had the second term, where this one we have the fourth term. So if you need to kind of write this out, here's your 4 terms, right? First, second, third, fourth. We know this one's 32. And if you move this direction from first to second, second to third, third to fourth by multiplying by 4, you can go backwards this direction by dividing by 4. And so the first one would be 32 divided by 4, which means the third term had to be an 8. Moving back another step, divide 8 by 4. The second term had to be 2. And then moving back one more step, 2 divided by 4, well, that's 1/2. So in order to get to 32, by timesing by 4, we had to start at 1/2. So that first term is 1/2. All right, so a sub 11, 1/2, 4 to the 11 minus 1. So we want to have 1/2. So you can put 0.5 or you can put 1/2 in there. It's up to you. This was base of 4 to the power of 11 minus 1, so power of 10. And yes, we do expect it to be just over 500,000 because once again, this is a base of 4. And so that's going to grow pretty fast. So we have 524,288. Actually, the same as the first one, right? The only difference between number 13 on this page and number 21 is number 13 was multiplied by -4, where this one's multiplied by +4. All right, and last but not least, we have a sub 3 is -64, a sub 2 is -16. Find a sub 9. So we are going to go ahead and write the equation. We don't know the first term, and we don't know what we're multiplying by. So we have two pieces of information, right? We know that it'll be to the power of n minus 1, but we're missing a sub 1, and we're missing the r. And so we have to figure out what's going on here. So let's go ahead and we have 3 terms because we have a sub 3. So that one's 64. This one's -16. So the question is what happened here? Because what happened there is going to give us our r. So what did 16 multiply by to get 64? I know they're negatives, but what happened there? And so you can just kind of use your calculator. Well, we know 16 times 2 is 32, right? So I'm thinking maybe 16 times 4. It is. 16 times 4 is 64. So this got multiplied by a +4, which means that r has to be +4. Now going one more step backwards, because we have to have that first term, what got multiplied by 4 to get -16? So you would divide, right? Going this direction, you can divide by 4. So that would be -4. So the first term is -4. All right, so use your equation to find the 9th term. So -4, parentheses 4 to the 9 minus 1. 9 minus 1 is 8. So that makes sense, once again, to have a relatively big number because we have a base of 4. So it's being multiplied by 4 every time. It's not as big as the last one because this one's only to the power of 8, where the last one was power of 10, right? So it just got multiplied more times. 262,144. All right, so the next part of your homework is to do all of the evens on this page. So if you want to pause the video and do them now, or if you want to just keep going with the video and come back to them, that is fine as well. And then last but not least, we're going to find term numbers. So this one, kind of switching it up a little bit. So it says, using the following sequence, determine where each value falls. So tell me where it falls. What is n? Is it the 10th term? Is it the 12th term? Is it the 15th term? Like, what term is it in the list? All right, so it says, given the sequence -7, 3, 13, 23, which term of the sequence is 313? It's not saying what is the 313th term. It's saying, hey, what n number, what n did we plug in? Where does 313 fall? If I were to continue this list, I would get 313. What number would it be in the list? That's what we're asking for. So the best place to start is first identify what kind of sequence it is. This one's arithmetic, right? It's adding 10 every time. So we can actually write ourselves an equation here. A sub n would be -7 plus 10 times n minus 1. And we want to know when do we get, what n value do we plug in so that we get 313. So when does the sequence have the 313 value? So we're trying to figure out what is that n that we have to plug in there. So there's actually 2 ways that you can do this. The first way is you could go ahead and solve this equation. This is a linear equation, and you could do it. You would distribute, combine like terms, move some things over, you would get n. and that would work. The problem with that, though, is it works for arithmetic ones because they're linear equations, but it doesn't work so well for geometric because those are exponentials. And we really haven't gotten into the nitty-gritty of how to solve exponential equations. We kind of touched the surface on some of them, but we haven't really gotten into how to solve an exponential equation. That's something that you'll talk about in either pre-cal or dual credit, whatever class you take next year. And so a good way to go about these problems is you can always guess and check. So you can always use your calculator to try to figure out what that end value would be. So for this first one, it'd be -7 plus 10 to the n minus 1. So you just pick n values that you think would give you 313. So I'm going to start with 10. So 10 minus 1, and I get 83. So we are not there yet, right? I have to go up. So I'm going to go ahead and change that 10 to a 15. Oh, still not there. And I didn't get very close by only moving up by 5. So I can go back up, change this equation. I'm going to jump for it. I'm going to go 25. Still not there yet. So my guess is 35. Oh, we're close, but we're a little too much, right? And so since it's adding 10 every time, I bet if we drop this down by 2, since it was 20, we were too high. There is what we're looking for. So by guessing and checking, we can see that it's the 33rd term. So we would say n is 33, and you could say a sub 33 is equal to 313. What we're looking for is the 33rd term. So if you were to make this list and write it out, it would be the 33rd term. All right, I want to show you what I mean for a geometric sequence, and then I'm going to let you try the rest of them on your own. So 27 is definitely a geometric sequence. We have 2, 6, 18, 54. And so what are we doing here? We are timesing by 3. So our equation would be a sub n equals our first term 2 times 3 to the power of n minus 1. And we want to know, when is it 86 million and some change, right? So 86,093,442. What n do we plug in so that when we do this calculation, we end up with that value there? So because it's an exponential, my guess is that's why this is so big, right? Base of 3. So this is probably a ways down the line, probably not as far as the last one at 33, but we're going to go ahead and give it a shot. So 2 parentheses 3 to the power of n minus 1. So let's go ahead and let's start with 20. I just picked it randomly. Let's see how close we get. Definitely not the right number, but the question is it too high or too low? So if you count, that's 3, there's another 3, and there's another 3. So that is definitely too high. So we're going to want to drop this down. So I'm going to go down to 15. And at 15, we have 9 million, it looks like. So that's a little low. So let's go 17. 17 is the right number. And so by guessing and checking, we know that n is 17. So the 17th term, a sub 17, is equal to this 86 million number. Now, in terms of doing the actual algebra, you don't know how to solve this equation here yet. You could probably get close, would be my guess, with just what you know already about exponentials, but you don't necessarily know all the nitty-gritty that it would take to solve that. And so because of that, a guess and check method is actually a really good method to use here. So you're like, wait, you're teaching us how to guess and check? And the answer is yes. It's a really good strategy when you know some things about geometric, you know a little bit about exponentials, but you're going to solve maybe an equation that you couldn't otherwise solve without it. So on this page, you can, if it's arithmetic, you could solve it algebraically. If it's geometric, you're probably going to struggle to solve it algebraically. But in either case, it doesn't matter, arithmetic or geometric, to figure out what term number it is when it falls in the line, you can go ahead and just guess and check for all of these right here. Just guess and check and see what you come up with. All right, so your homework is to finish these guys as well. So you should have all of the odds on the first page, or evens on the first page, all the evens on the second page, and then you have 26, and then the rest of these 29 through 32. So pretty much all the evens with a couple extras thrown in there. If you have questions, please let me know. I am here to help. You will have a quiz when you come in on Wednesday, so be prepared for that. So please reach out with your questions now as opposed to later.